So today we're going to go through solving kinematics problems graphically. So I'm in your workbook, and I think it's about page 126, and I'm looking at problem number 6. So the first thing is they tell you the information, and then they want a well diagram of the situation, so we're saying a motion map. So it looks like this dog is traveling first, and it's a constant speed. So we'll say this is 0 seconds, 2 seconds, 4 seconds. And I'm doing 2-second intervals so I don't have to draw so much. 6 seconds, and then 8 seconds. Now, at 8 seconds, he starts to increase his speed for the next 5 seconds. So I'm going to still keep doing 2-second intervals. So at 8 seconds, this would be 8 seconds. This should be getting longer. 10 seconds. 12 seconds. And then 14 seconds. Okay, so that's our motion map. Now, two things that we need to remember here. One is that the slope of a velocity versus time graph represents the average velocity, or average acceleration. That's one piece of information we need to remember. The second one is the area under the graph represents the displacement. Okay, so those are two important pieces of information we need to remember. So I'm going to get rid of this because we're going to show you how to solve this graphically. So the next thing is make a graphical representation of this. So if I graph this, I'm going to say this is 5 meters per second and this is 10. And I'm going to go by 2-second intervals. It was constant, and then it increased up to 10 for the next 5 seconds, so that was to 13 seconds. It looks like this. Okay, so I did the graphical representation of the motion. Now, they want you to determine these two things. One is they want the acceleration during the second part of the motion. So that acceleration is occurring right here. So for that, we're going to calculate slope. Okay, so average acceleration equals the change in velocity over the change in time. So we're going to take the velocity final minus the velocity initial over the time final minus the time initial. The time final is 13 seconds minus the initial time would have been 8 seconds when it started to do this, and then the velocity final would have been 10 meters per second minus 5 meters per second. So it looks like we get 5 meters per second divided by 5 seconds. We have an acceleration of 1 meter per second each second. That means he's increasing his velocity every second by 1 meter per second. Okay? Now, the next one they want to know is how long is the driveway? So we want to know what is the distance the person or this dog covered. So we can relate that to the displacement and just leave the sign off of it, because displacement would be what direction did he go in? Well, we're not worried about the direction, so we're not going to worry about putting a sign on this. So for the displacement, it is the area underneath here. So it's all of this area. Okay, now if I look at this, I have a rectangle here, and then I have a triangle here. So it looks like my area equals the rectangle plus that triangle. So it's base times height plus 1/2 base times height. Okay? So if I look at my two measurements for that rectangle, it looks like the height is 5 meters per second times the base is for the total time is 13 seconds. Seconds will cancel, plus 1/2. The base of this is from 8 to 13 seconds, so that is 5 seconds. And the height is from 5 to 10 meters, so it's 5 meters per second. So doing my calculation, 13 times 5 is 65 meters plus 12.5 meters. Looks like I get 77.5 meters. If I went to sig figs, there would only be one here. It would be 80 meters if they asked you to do it in sig figs. So we are emphasizing how to solve this graphically by using the slope and using the area underneath the graph for a velocity versus time graph. A velocity versus time graph is going to give us more information because we have a constant slope or else we have no slope, and we can calculate the area underneath those very easily. You are to finish up worksheet number 5. Do all of the problems except do not do number 3, I believe it is, and number 8. So do everything but 3 and 8.